Welcome back to Locat TV. Setting appropriate service level and safety stock targets is tricky, and there are any number of options on the market and vendors trying to sell you answers. One such tool is ABC XYZ Analysis, and here to help me analyze it, Locat founder Joannes Vermorel. So Joannes, let's start right at the beginning. Service level, safety stock, all of these inventory policies. Why are they so difficult to set? Because there's a plurality of options trying to answer these questions.
So first, what we see as subproblems are not really subproblems. If we say, let's pick the service levels, and there is an implicit assumption that picking the service levels is in some way easier, simpler. You know, it's supposed to be like a smaller part of a wall where if you could do that and then you would do other things, as opposed to just decide right now what you should replenish or produce. I mean, depending on what sort of inventory control you have in mind. So you see, the implicit assumption is that we have decomposed a problem. So the problem is picking the right quantity for inventory to be produced or stocked or allocated. You know, there is variations. And implicitly, when you say service level or when you say safety stock, it is implicitly a decomposition of the problem. And what I very much challenge is that this decomposition is actually delivering the intended effect, which is to be simpler than the original problem. My counter argument would be when you go and at the service level problem, you are facing a problem that is exactly as difficult and as challenging as your starting point. And thus, although you phrased your problem differently, as I am looking for a service level instead of I am looking for a quantity that right now I should replenish, the problems are essentially the same. And thus, it's no surprise if you, as soon as you realize that it's pretty much the same problem, that service level isn't any easier than the direct determination of the actual quantity to be replenished. And when I say that it's no easier, I say that any sort of subtleties, any sort of nuance that goes into deciding the actual quantity to be replenished, produced, allocated, etc., will be involved in deciding what is exactly the right service level. And that's in this sense that I'm saying those problems are exactly as challenging and difficult, even if it looks like safety stock and service level are seemingly simpler.
So if you could then reframe the problem in your own terms, how do you see it, like succinctly?
So the way I see that is that in an inventory optimization settings, is that we are trying to come up with a decision. The decision is the thing that is tangible. So the thing that is tangible is how many units do I allocate, how many units do I produce, how many units do I purchase. You know, I say it's tangible because this decision will have very tangible consequences on your supply chain. You know, it's not just an idea. If you decide that you allocate 10 units to this store, then those units are going to be sent in the store and they won't be available anymore in the warehouse. This is very, very tangible. As opposed to, let's say, I decide to have like 97% of service level in this store, which is, I would say, an abstraction. You know, there is no such thing as 97% service level. It is just potentially a useful artifact, but this is an artifact. This is not something that has a tangible counterpart in your supply chain. And even if you want to do your service level measurements, for example, it's not going to be something that you can, there is no such thing as obvious service level measurements. You will need to measure that over a period of time. Which period of time, that's an open question. You will need to average out over a list of products, possibly. Which list of products, that's another open question, etc., etc. So when I say, you know, it is an abstraction, is that we can see that the service level comes with tons of open problems that you don't have when you're dealing with a decision. If I decide to take those 10 units and I put them in the store, there is zero ambiguity. I can measure afterward that I decided to allocate 10 and that 10 have been effectively moved, just compliance with the decision, but there is nothing, fancy about it. It's just straight one-to-one correspondence between the decision and the implementation, which is absolutely not the case if I'm looking at service level. If I decide that I will have 97%, first, that's a decision, but if more clients show up, I will not, than I was expecting, I will not actually get 97% service level. So you see, it's already kind of a forecast and a projection. And then again, it will depend on the scope, which list of products, which time window, etc., etc. Again, that's typically the sort of all the oddities that you get with an artifact, as opposed to, in terms of information, as opposed to something that is just a tangible reflection of the base reality of your supply chain.
And how much of what you just described is actually captured using a tool like ABC XYZ Analysis or its predecessor, ABC?
So now, the interesting thing is that why do we have these sort of things in the first place? People, supply chain practitioners, they want to end up with the decision. And there is something that is a little bit, I would say, and there is a twist, is that if you just look at the numbers and say, I guesstimate that I need this and this and this and this, line by line for my store today, product by product, exactly the quantity I need. It's a very, very low-tech way to do it. And by the way, there are plenty of stores where store managers are still doing it like this. So they just, think a little bit. They have their habits, their experience, and they just decide exactly how much they need. And they don't go into any kind of, sophisticated or semi-sophisticated analytical process. This is just guesstimation all the way down. And it works, Now, the thing is, this method looks very crude, and so people think about what about refining that, and then they end up with a problem, which is they have a lot of products, and they think, okay, the person looking at the list of products, due to the fact that there is 5,000 products, in the store, let's say, this person is probably not going to revisit the case for every single product every single day. Thus, we need some sort of attention prioritization mechanism. You can prioritize by just sorting the products from the highest sales volume to the lowest sales volume. That will give you a priority list, and then you can go down starting from the top and go down, and you may decide that every single day you're going to go down the first 10% of this list, and then once a week you will do half of the list, and then the complete list you would do it only once a month. That's one thing that you could do. And that's pretty much the essence of ABC. ABC is just about having that. But the interesting thing, then ABC XYZ is, I would say, a variation on this case. But again, this is an attention prioritization mechanism intended for humans. So now, once we are at this point, I think we should, again, challenge what is the problem that we are trying to solve. Because again, we started with the problem was we wanted to pick the right inventory quantity, to be allocated, produced, purchased. Again, that is something very tangible, very direct. And now it seems that we went from this problem to another problem, which was kind of picking service levels or picking service stocks, and then we are into yet another problem, which is attention prioritization. And you see here, the pattern that is starting to emerge is something that is in software known as yak shaving. So you were actually looking to do something very straightforward, like I want to, let's say, upgrade Windows 10 to Windows 11. That's what I want to do. And then you end up doing something impossibly weird, such as I am doing all sorts of things where I'm opening up computers, changing nuts and bolts into the computers. And then when people ask you, but why are you doing all of that? They say, oh, because this next version of Windows has some kind of new requirement on the hardware, and there is one part inside the computer that happens to be at the hardware level incompatible with this and that. And so you had something that you had like a very, very straightforward goal in mind, which was, I just want to go from version X from the software to version X plus 1. And then you have completely deviate along the way to do something that is largely, I would say, you've been sidetracked in doing something that is only very tangentially connected to the original task. And here, that's exactly what we are doing here with our inventory optimization problem. We were dealing with a problem that was, let's pick the right quantity to be allocated, produced, purchased. And now we are trying to solve a problem that is, and that would be my argumentation, that is much more complicated, which is, if I have to involve the human, how should I actually organize the information to be presented by this human? But you see, this is a very, very complicated problem. And it is absolutely not clear that resolving this problem is actually the best way to obtain an answer to this question. If we say, for example, I have two numbers, I want to add them, so I just want to design a circuit to compute the addition. Okay. Should I really think about the problem as in I should be able to present the intermediate steps inside the machine that I'm building to a human to verify that the addition is correct? That is orders of magnitude more complicated than actually designing just a circuit to do the addition. You see, if I say I want to do the addition, design a circuit, for that, and on top of that, have the system designed in such a way that I can involve a human in the middle of the loop, that is much more complicated than the original problem. So my criticism here would be on this ABC XYZ is that we started from a problem that was seemingly very complicated. It is actually quite complicated. And we tried to decompose this problem, but the way we approach it is, I believe, slightly misguided, and we have been sidetracked. And now we are actually trying to figure out another problem that is almost like empirical psychology, which is how to organize the proper attention prioritization for humans. But the other way to look at the problem is, well, if you're going to use a computer to solve this problem in the first place, why do you need to prioritize the attention of the human? You will just have the computer just solve the problem for you, period. And just like when you have a pocket calculator, you don't expect the pocket calculator to prioritize your attention on the carries that have to be, carried over for your addition. That's like a technicality and a detail that is best left to the machine. You don't need to be, involved at every step of the process.
Well, if I can push you a little bit on that, because I followed, but as a proxy for the audience, I understand ABC analysis based, generally speaking, on either sales volume or sales revenue. So we decompose our SKUs into three categories. ABC XYZ adds a second dimension, generally demand variance. And if I understood there, you were essentially dismissing the quantification of demand variance as a tangential concern. Could you explain why that is?
So you see, we started with a problem that was, we want to have the right inventory decision expressed as a quantity. We realize that if we plug a human in the loop, the human has a limited capacity to process information, so we need to prioritize that. Mm-hmm. If we just do a basic prioritization from highest sales volume to lowest sales volume, we end up with ABC if we just divide this list in terms of chunks.
Yes, set thresholds. Yeah.
Now, the thing is, once we have that, we need, again, from the perspective of having a human, we are looking from a way to support this human operator further in helping this person in having a sense of what would be the sort of safety stock and service level that would be appropriate for each one of those lines. But again, this is, you see, we are again, decomposing, you see, there is a premise that we are already decomposing the problem in a way that is nice, that is, I would say, suitable for the human mind to process.
Okay.
And that's also, so yes, the XYZ is to add another dimension, which is going to be the variance. Say, well, we have the volume, but then we have the sort of ambient erraticity, and we want, out of a big chunk, let's say we have the first chunk, that's our products that are sold the most, we need to introduce a second dimension that would be the degree of noise or variation or erraticity that there is among this list. So we
fluctuations.
Have, so we just took the first, let's say, 10% highest seller of our products, but now we want to subsplit this list into chunks that represent the degree of ambient variance for every product. And so you can think of it, instead of having just a list of segments, you have like a matrix. And that's ABC XYZ for you. But again, this is fundamentally something that is very much engineered as a method for the human mind. Because the question that you should ask yourself is, if I want a machine to do the end-to-end process, is there any benefit in doing all this segmentation? Does it do anything for me to resolve the problem? And I would say not at all.
Well, critics would presumably point out that by creating, generally speaking, a matrix of 9 categories, that you can identify the variance and the highest contributing SKUs, and then you can set appropriate levels, like how much safety stock do I want for that, what is the level for each SKU, and that there is a variation between AX and CZ, for example.
Let's even assume for a moment, let's even assume that those 2 dimensions are informative. I very much challenge that, but let's assume that those volume and variance are informative. Well, from a computer perspective, why would you consider chunks, discrete chunks? Why would you consider like having half a dozen of subgroups for the volume and half a dozen of subgroups, for variance? From a computer perspective, you could just use the ranks. So you can rank the products from rank number 1, highest sales volume, to 1,000 latest least sales volume. So you can have a number that gives you the exact rank, among your portfolio for the volume, and then you could do the same for the variance, where you just have the ranks, and the ranks give you strictly more information. If you look at your classes, in the sense ABC or XYZ, the class is just an approximation of the rank, and this approximation serves only one purpose: to be more digestible by the human mind. But from a computer perspective, you just keep the rank. The rank gives you strictly more information. The class is a lossy representation. You lose a lot of information. And there is nothing good that comes out of this loss of information. So you see, again, so if we say that those 2 dimensions are relevant, I'm not saying they are irrelevant. I'm just saying that as far, dimensional decomposition of your problem goes, those dimensions are very arbitrary, and it's not very, very clear that it's actually the best way to go at it. But if we just look at those 2 dimensions, I say that if you just preserve the ranks, you will have something that, as indicators, you will create a pair of indicators for every single product that is a pair of rank. And this pair of ranks is strictly more informative than your pair of classes. And this pair of ranks gives you a lot more information than your pair of classes. So you see, that's again, my criticism is that, again, we see here that it's not just a method that comes with the volume and the variance being of interest. It is very much engineered from the start to have a human mind as the processor of this information. And that's where I really challenge, why would you want that in the first place? We have super powerful computers. Do you think that there is something that requires the human soul the core, I would say, you mean so to take those inventory decisions? Do you think that when we look at a store that has 10,000 products, all those things are kind of rotating every day. Do you think that there is something for the person that is going to spend, on average, something like 4 seconds per product, that there will be something like a spark of genius injected into that? You know, I'm not challenging that the human mind can do things that are incredible when given time and resources. You know, if you take Albert Einstein and you give him, you know, months, years, it can do that. This sort of minds can do things that are incredible. I mean, way beyond what we can do with machines. But this is not the context in which we operate in supply chain. I mean, people are under immense pressure to just get the things done. And so if we look at how many seconds of brain power you will be able to allocate per SKU, usually it's very little. For most industries, it's going to be a matter of seconds per SKU per day.
In terms of the categories, because again, we've discussed the categories, but we haven't discussed how the categories are calibrated. That's the result of multiple human minds, as far as I understand, yes? Again, the difference between thresholds.
But again, if you see, once you see that you can have the ranks, and now you can decide with percentiles that you're going to have a split, and you can say category A is up to the percentile 10%, you know, it's top 10%, yeah. Or percentile A is top 2%. Because when you plot all the products from the most sold to the least sold, what you get is almost invariably, that's a point that I touched in one of my lectures, a zip curve. Yeah. So what you see is a curve that is completely continuous. So there is no plateaus. It's not like a stepwise functions where you have like areas where you just drop and would have like discrete splits. It's something that is completely smooth. It's a zip distribution. And so I really challenge when you have a curve that is completely smooth. It's a bit like, you know, you remember those old video games when you had a circle and to approximate a circle, you just do a polygon. And if you do a polygon with like an octagon, that's like a very low resolution circle. And if you add more and more edges, you will get something that is closer to a circle. And visually, if you have like thousands of edges, you will get something that visually very much look like a circle. But here, what you're saying, what I see is that as if you're trying to approximate a circle with a square. If you have like 4 classes, what you're effectively doing is you approximating, you know, your circle with a square. And if you have like 5, you will have a pentagon, etc., etc. So you see, the more classes you add, the better your approximation. But in the end, you know, if you just remove the approximation altogether, what you're left with is the rank of every single product. So I would say, you know, just don't introduce the groups, stick with the ranks. And if you assume that those 2 dimensions, volume and variance, are useful dimensions, again, I challenge that, but that's another discussion. But if you assume that, then anyway, those ranks gives you a more informative version of those 2 dimensions, strictly more informative. And any subgroup, any grouping mechanism that you do introduce will degrade this information.
Well, again, that transitions very smoothly to essentially the basket perspective, which is something that I'm really, really interested in terms of answering this problem. And that treats SKUs in combination rather than isolation. And how would that fit into this conversation?
So here, you see, again, we started with a very simple problem, at least simple in its expression, not necessarily simple in its resolution, but simple in its expression, which is pick the right inventory quantity to allocate, produce, purchase, or something. Okay. Now we have been sidetracked, and there is, I would say, a widely used method which involves service level and safety stocks, but I really challenge the validity of those methods. And among those, you end up with the idea of picking your service level. So first, let's pause a second. Where does this service level perspective comes from? It comes from historically people were doing incredibly simplistic assumption on the future demand, and they were just saying, I have a forecast, I'm just going to have like I'm going to say that my error, future error about the demand is normally distributed. Same thing for the lead time. Surprise, surprise, the uncertainty is not normally distributed, but that's again another problem.
We'll come back to
and
that.
And then once I have my normal distribution, which is a Gaussian, I can pick, I have one parameter, the quantile that will give me in terms of, that's the same thing as the service level. I pick that will give me a target quantity that I should maintain for my inventory. And that's what this safety stock, the safety stock is the result of what you get from this delta between the mean and the quantile when you look at a distribution, a one-dimensional distribution, once you have your service level. So the service level is a parameter of your safety stock method. Now, the thing is, due to the fact that it is a normal distribution, it goes to infinity right and left, pretty much by definition. So by the way, the classical safety stock model gives you some weird stuff such as negative lead times and negative sales, which are very, very weird, but they are part of the model. But that's another sort of problem. But then, so that means that you can pick a service level, a value, and that can give you any target stock value between plus infinity, minus infinity, depending on how you choose your service level. And again, this is not theoretical. This is literally what the math tells you.
Yeah.
So whenever you have a Gaussian, you pick your quantile, and that can go, the final cutoff that you will get is anything between minus infinity and plus infinity. So effectively, once you've realized that, you realize that your service level is strictly identical to picking the quantity you want to replenish. In the end, it's just for any quantities that you decide to replenish, there is a matching service level as understood as a normal distribution that you inverse and where you pick a quantile that matches the service level. So it's not just an analogy of mine. It's literally a mathematical equivalence. You pick you have a quantity that you reorder. If you have like a service, you have a safety stock model that you have on this queue, then there will be for any quantity one matching service level in this normal distribution setting. Now, so if you are under the illusion that somehow picking this service level just because it is a percentage make it easier, I would say it is mostly an illusion. But then that's what people do, because the only slightly good thing, but it's not that good, but the only slightly good thing about it is that you've normalized the scale, kind of. The problem is that all your products have varying volumes and variance, and so again, the human mind is slightly confused by those dimensions. And if you go for a service level target, it is a way to express your quantity to be allocated, purchased, produced, in a way that is somehow volume independent and variance independent. That's kind of the gist. So but again, this is kind of very weak, and that's where we get to the basket thing, is that when you say service level, you would think that's something that is very misleading, because it looks like if I have very high service level, it seems like it's going to be perceived positively by my customers. And I would say, not at all. That's, don't get confused by the math. This is absolutely not something, the math of the safety stock model doesn't say anything about the satisfaction of your customers, not in the slightest. That's completely non sequitur. So people go from, I have a mathematical model that is like a complete abstraction with a one-dimensional distribution. I can pick any value for this between 0 and 1, which in the end will result in a stock position between minus infinity, which is weird, and plus infinity. And then they say, oh, but if I go for something that is very close to 1, so 100% service level, it must be good for the clients. And there is a completely non sequitur jump where we jump on that.
Keep going.
So what is the problem? The problem is it is very naive to think of your quality of service as if it was a one-dimensional problem. It might have been true, let's say, in the 18th century for a bakery, where there were some people that were selling one product like bread. And you have like one type of product, literally. So that's only one. It's one-dimensional. Is that, do I have enough bread, not enough bread? And there is like one product, and this is it. It still exists in some, commodity markets. If you want to buy, let's say, something like a very sort of calibrated. If you want to buy maybe salt for the road and it's super calibrated, yes, that will be like a one-dimensional thing, just the quantity matter and the rest is irrelevant. But almost any modern supply chain is never dealing with one product. I mean, we are dealing with thousands
of SKUs, different
if
networks
not
of stores.
Tens of thousands of products. And then if we look at SKUs and we multiply by the number of locations, we are easily into the tenth of thousands of SKUs, if not hundreds of thousands of SKUs, if not millions of SKUs for large companies. Thus, this large this large number of SKUs, it really challenged whether this sort of one-dimensional analysis, does it really make sense? And because you see, sometimes at some point, a difference of magnitude becomes a difference of a kind. It is more products, but the sort of emergent properties that you get when you have like tons of products are very, very different from what you had when you had just one product.
When you say emergent properties, again, I understand, but for people who might not understand, expand on that, please, because that's an important detail here.
Yes, I mean, you see, the sort of emergent property is that if you want to study, let's say, a molecule of water, that's something relatively simple, and I would say it can be described, to a student in high school in probably 30 minutes, giving you a relatively accurate-ish picture of what the science knows about a molecule of water. Mm-hmm. And that's something that is just an element. Now, if we have like tons of molecules of water, like billions and whatnot, then we have like water in all its form, which can be gas, liquid, and whatnot, and you can have all sorts of behaviors that are very, very complex. And if you wanted to explain all the sort of things that you can observe with water, suddenly it would take weeks or months. It's not something where you can just pick a molecule and in 30 minutes cover, what science knows about just a molecule of water in isolation. If you want to know all there is to be known about, I would say, large aggregates of molecules of water, you get everything from the oceans, from the lakes, from the rivers, from the clouds.
The interpolation of water.
I mean, that's water in all its form is absolutely gigantic, and there is like absolutely baffling diversity of stuff that would fit this definition. And that's you see, there is a danger you cannot leap from saying, once I know everything there is to be known about one molecule of water, I know everything that there is to be known about water. Not quite. And that's the sort of danger, is that when you say, I have one product, I have a model that explains one product, and so now I have everything that I need to explain my supply chain, which is made of many, many products. I say, hold on. There are plenty of things that are not even conceivable in your one product setup. This is a toy example that does not reflect in any way the sort of true complexities that you have in your supply chain. I mean, first, this sort of even if we stay with just one product, before jumping to the basket,
ground up.
First, things varies over time. So if you look at a product, you can have all sorts of variations, just one product in isolation, and if I challenge, again, this ABC and whatnot, you would realize that even if you look at one product in isolation, the rank would fluctuate widely over time. And if you have like cutoff to say, is this product like a top seller or a slow mover, this product would jump between categories, over time. And most products have a life cycle where they are going to start slow, ramp up, plateau, and then be sensitive at some point. So this one-dimensional thing, it looks as sales volume as if it was like something static. It is not. That is something very dynamic. So you see that's another dimension that is very much absent. And again, that's part also of what would be your quality of service. There is those dynamic, I would say, time-dependent sort of behavior. Because again, we are looking at things from the eyes of the clients. If I take back my example of bakery, clients are expected every single day to go to the bakery and find the bread. Any stock out is going to be a breach of the social contract that there is bread because I need this slice of bread for my lunch today. So that's very critical, and there is only one product, so people have like an incredibly firm expectations. On the contrary, if you happen to have, let's say, bread, but you're very cheap and quite unreliable, and you have only bread, one day out of two, then people would have a built-in expectation of your service that there is just bread one day out of two. And they might still, if you're way cheaper for some reason than the competition, they might still be happy with you showing up only randomly one day out of two with much cheaper bread. So you see, the quality of service, even if we stay with just this one product, we see that there is plenty of other angles that are built, and we see here, I'm just touching something which is the quality of service is not something that is in your supply chain. It is fundamentally something that is in the eye, in the mind of your clients. And you have many clients, and so not everybody will agree on that. So it's not even consistent. And beware if we have aggregates that can be also very, I would say, misguiding. Now, if we go back to finally to the products, to the baskets, sorry. Now the baskets, it adds another important dimension that if people want multiple products, we are going to have a look at will they find the list of stuff that makes sense at the same time. And here there is a mistake, a mathematical mistake to be made, which is if all my products have 100% service level, then all combination of products have 100% service level. That is true, except that you never have 100% service level because, again, 100% service level is plus infinity quantity of stock. So you never have that. So you always have something that is much lower. And when you start looking at the sort of resulting probability of availability of or unavailability of combination of products, you end up with a vision that is very, very different from the one that the safety stock / service level one-dimensional model can give you. That's something that is very, very different. And to the point that it is, just to illustrate that, if we say in a supermarket, you say that, let's say, this supermarket is quite good, and they have something, let's say, a 95% plus service level on all their products. Quite good. By the way, in Europe, I think that on average there is like 7% stock out of the shelf. So 95 for the shelves is not that bad. If you have a client that walk into the store and that want 20 products, that's not even a large basket. Once a week you come, it's not 20. It's probably not even such a large basket. The probability that there will be at least one of those products that is missing is probably going to be something I don't have. I would need to do the math. But if we assume that all those products have kind of independent availability, which is very abusive, but you would have probably something like less than 10% chance of finding everything. So we start with something that looks like very, very good, like from our safety stock perspective, from our Gaussian demand perspective and whatnot, we are under the impression that we have like 95% plus service level, whatever that means. Again, this is a mathematical model. This is not something that exists in the mind of the client. But from the client perspective, it will mean that less than probably 10% of the client who walk into the store will actually find what they were looking for.
Exactly.
And that's, so you see, that's And at the same time, those two things can be true at the same time. You can have like 95% plus service level everywhere, and yet have less than 10% of your clients who walk away from the store happy. And that's not even the worst. The worst is what about the products that your client expects but are not part of your assortment? Because you see, the service level is blind in the sense of what if there is a product that is very much in demand that you just don't have? It's not going to count as a stock out. It's not going to count as a 0% service level. It's just not going to be counted at all. Mm-hmm. And so you're going to say, well, for example, if I go to the extremely bad example, just imagine a store filled with products that nobody wants. So people never buy any of those stuff. So you have like 1,000 products on display, but nobody wants any of those products. Well, this store has, by definition, 100% service level. Perfect. You have like products on display, nobody wants them, 100% service level. And that's something that is just the result of the bias through the assortment. The more products you have that nobody wants, the better your service level. That's completely mechanical. And that's why we have, again, that's the problem with those mathematical models, is that you have to be very, very cautious, especially when those models have been named after positive values, like safety stock. There is like safe. It's probably better if it's safe. But is it? Again, there is this sort of non sequitur transition where you have a model that is a mathematical model that has a good name. It's a safety model. It's very safe. And then people jump into it's safe, it's good. And it's good for the clients. And say, hold on. You made a huge jump that is just completely unwarranted by the mathematical definition of the object that you're looking at.
Well, if I can just jump in there and summarize that, and feel free to cut me off where I'm wrong, because again, I think that's a critical point to understanding our overall critique of ABC XYZ. The basket perspective. There are certain people buy in combination. They don't tend to buy in isolation. Thus, not having access to a certain SKU, for example, let's say a CZ SKU, which is in this matrix, contributes low overall value and has a lot of variance. But there will be certain situations, certain probabilities where I came into the store for that. That's the critical reason I'm here. I can't get it. Thus, I exit the store and don't purchase any of the other B and A grade SKUs. So I lose, the store loses all the sales, not just the individual CZ SKU.
Yes, and again, if we go back to the sort of original intent, ABC XYZ is supposed to be an attention prioritization mechanism intended for human. Is it, even if we say, let's stay with the premise that we want to have a human in the loop. Okay, we want to have a human in the loop. Then the problem becomes we want to prioritize the attention of the human. Is it a good mechanism to prioritize attention? And I would say absolutely not. Absolutely
not if it overlooks this dimension. No.
It's
blind to this, is what you're saying.
Yes, it is blind to this and tons of other
tons
problems.
of others. Yeah.
So you see, as a prioritization mechanism, it is very, very crappy. It is not.
What do you really think, Joannes?
It is not bubbling up anything that is that has any kind of true relevance to what is really at stakes. So here I would say no. It is actually a fairly bad mechanism in terms of attention prioritization. And
please.
Yeah.
No, please.
And if I had to concede, I'm not, as a rule of thumb, I'm not a big fan of DDMRP. But if I had to concede one thing to DDMRP is that as an attention prioritization mechanism, the way DDMRP define buffers and prioritize products against their divergence to the target buffers is a lot more sensical as an attention prioritization mechanism than ABC XYZ. It is, at the very least, it is something that as an attention mechanism is probably halfway decent. ABC XYZ is not.
Is there any way to reconcile ABC XYZ as a attention prioritization tool with everything that we've just described, particularly the basket perspective? Is there any way to merge these concerns?
No, that's the problem. You see, that's the thing is that you have you start with a series of bad premises. First, you say, I want to have a human in the loop. I challenge that. Okay, it's not very good. Okay. But then you make a second mistake, which is let's go for some sort of mono product, mono SKU, model with some kind of normal distribution assumption built in. That's very, very bad. And then you make another catastrophic assumption, which is that somehow having a discretization of your space, in terms of products, is going to add information. No, it's going to lose information. So you see, we have been sidetracked in sort of tensions that goes worse and worse. And now we realize that as we have been sidetracked quite a lot, we realize that we have plenty of defects that are accumulated. And now we are trying to duct tape by, we have been sidetracked on this service level. We realize that there are plenty of defects. So we try to duct tape that by re-adding the variance that give us the ABC XYZ. And you could potentially try to find other ways to duct tape this method, but the reality is just you're going into the wrong direction. So everything that you can do on top is just going to pile up duct tape, and it's just not good, I would say, engineering. So the method, the process that you're actually crafting, it's just not very good, and piling up duct tape is not going to make it better. And you see, so here the only solution is to walk back and say, revisit the sort of assumption that you made and say, are they really valid? And if not, then you should reconsider entirely the very approach that you're taking. So you see, the way, again, if we are back to this thing, we started with our tangible problem that was making the decision for the inventory, and then in the journey we had, in how we approach the problem, we made a lot of assumption, and we are now facing the sort of consequences of the mistakes that we made earlier in our assumptions. And I would say, no, I mean, once you've made a lot of mistakes, it's a bit, when you ask a mathematician, okay, my proof is wrong, but can I actually, if I made a second proof afterward, can I make it right? And mathematician would say, no, you can't. You can have a bogus proof and then fix your problem through a second proof. The only way is to discard your bogus proof and redo the work, and then you can have like a path that is correct. And that's pretty much the same in software. If you have bogus assumption, you can't fix that afterward. You have to walk back to the point where you made a mistake, fix that, and then resume your journey. That's and here the problem is that I see is a lot of companies have built entire practices under fairly bogus assumptions. And due to the fact that supply chains are very opaque and complex, and that people can operate literally for decades not knowing any better. And by the way, there is also one big ingredient that I mentioned, is that when I say one of the problems was this idea of having humans in the loop, let me point out that it has only been 20 years since we had computer machines that were, I would say, capable enough to cheaply automate the supply chain decisions. So it has not, those machines, modern computers, have not been around forever. They have been around for a relatively long time now. I would say in a form that was capable enough to deal with the complexity of a modern supply chain, but it's not like they have been around with us for centuries. So for many companies, especially large companies that operate supply chain, something that only became like a possibility 20 years ago is not that old. Just to give you a point, for example, a point of comparison in time, it took about 40 years in the US and in Europe to go from companies that were producing their own electricity to purchase electricity from the grid. So it's, again, adopting a technology can be relatively slow. You would think that it's completely obvious that you don't want to produce yourself electricity, you want to purchase it from the grid. But the reality is that historically, at the end of the 19th century, beginning of the 20th, for both in Europe and in the US, it took about 40 years to completely transition from I have a generator at home to I'm just buying electricity from the grid. So that's why I say, in terms of time scale, it is still a fairly recent development, the fact that we have machines capable of doing all those calculations without having humans involved at every step of the process.
Well, something I also wanted, it's kind of coming back a little bit, but you talked about the static approach of ABC and also by extension ABC XYZ. And I was hoping you could expand a bit on both approaches, or any alternative approaches actually, take on demand patterns. Because again, it might be beating a dead horse at this point, but it's worth pointing out.
You see, the problem is
details.
that I said we are classifying our products according to two dimensions.
Exactly.
The mean, so that's the sales volume, and the variance.
Mm-hmm.
Now, the thing is, those two things are again an abstraction. They are not real. There is no such thing as instant sales volume. That does not exist. That's the difference between tangible decisions. I move 10 units, I put them there, and I would say this product on average sells 0.5 units a day. There is no such thing as selling 0.5 units a day. The only thing that you can say is that over the last 2 weeks, I have sold something like 7 units, and that would give you approximately 0.5 units a day. Now, the thing is, again, this volume and variance, the mean and the variance, they are statistical indicators, and the question is that how stable are they over time? And that's the thing, is that we have done a lot of tests at LOCAD, and we have seen that for most businesses, even when we just look at ABC analysis, so we just have something like, typically companies have, when they want ABCs, they want more than 3 categories. They will have like 5 or 6.
Yeah.
So let's say 5 categories. When you have like 5 categories and you revise your classes only once per quarter, so that's relatively infrequent. Once per quarter is relatively slow. So you give yourself a lot, I would say, long time windows. 3 months is a lot. So even when you give yourself very long time windows, like an entire quarter, our experience was 40% of the products, for many products, would jump from one category to another at every quarter. So you see, products, it's completely unstable. So when you take decision, you say, oh, this is a product A, and thus there is this level, and thus I need to do that. But then next quarter, it's another class, and the decision is completely different. And this is not like an exception. This is literally 40% of the products will jump from quarter to quarter. And if you go for anything that would be even, I would say, more precise, as in per month, then the number of products that would jump from one class to another would be something like 60%. So the problem with this classification, and when you go into ABC XYZ, you have multiplied. So I said that you get this 40% quarter to quarter of jumps with only something like 5 classes. If you double the number of classes, you're probably, or let's say you have like twice 5 classes, so that's going to be 25, a matrix with 25 cells. Then you would, I don't remember the numbers exactly, but I would venture that you get something between 80 and 90% of the products that will quarter to quarter jump from one category to the next. At some point, if you say, okay, I'm building a nice matrix, but from one quarter to the next, 80+% of my products jump from one place to another, does it really tell me anything of value about my business? No, it's pure noise. It's pure noise. And that's why I said it is those indicators were kind of garbage, is that what you get is an illusion of pattern. You've organized the products on a matrix. It looks scientific. Maybe a consultant can sell you a mission just because there is like something that is scientific looking.
There are maths. There's maths involved.
Yeah,
it's impressive.
there's math involved, certainly, and we can do training sessions and workshops and end up with PowerPoints being produced and attributing certain interpretation to every single cell in the matrix. Remember, it's just ranks. We have just done cutoff.
That are determined by committee as well. We're determining the thresholds here.
Yeah, I mean, again, if you know that you have like a Zipf's distribution, and it's true both for the volume and the variance, you would see that this is a spectrum, continuous. So your cutoff are completely arbitrary anyway. It's by the way, when you want to think about those classes, just think as if you were doing classes of people and saying there is the rich, the average, the middle class, and the poor. No, I mean there is the rich. There is no such thing as the rich. You have like the extreme billionaires. You have the poor, but they are for example, do you classify a student that has that is fresh out of Harvard Medical School that is
$100,000 in debt.
$100 in debt just due to the fact that this student is out of medical school at Harvard? Does this person really classify as poor? I mean, you end up with
the taxonomy argument.
Plenty of problems with when you when you have like this sort of discretization, and that's the exact same sort of problems with your products. And the matrix just give this sort of illusion of science, illusion of methods, but it's not because you have like a fancy looking method that it is making any sense.
Well, how does a probabilistic approach, where does that fit in?
So the probabilistic approach is something that is, the problem is that it's very hard to compare because it's a change of paradigm, complete paradigm. So we are literally comparing apple and oranges completely. First, on at least two major fronts. The first is whether we need humans in the loop or not. The quantitative supply chain says, no, we want to have the very best that modern computing hardware can offer for supply chain. So, and that's literally in the kind of mission statement of the thing. The very best that the computing hardware and software can offer for supply chain. So whether it involves humans or not is relatively accidental, if humans are involved at all. And here, in this regards, probabilistic forecasts are very, very interesting because in terms of information, of richness of information, it gives you an enormous amount of information. So you see, we went from classes, I said you lose a lot of information, to ranks, which give you like a spot measurement. And that's, I would say, more precise. That gives you more information. But essentially, probabilistic forecast gives you, well, it's another way to say we want even more information. We can't really get a more precise rank. We just have the rank. It's a number. So you can't get more precise than your product number 10. There is, it's literally an integer. So there is no more precision than that. If you want to have more precision, you need to switch to a different kind of precision. And it's going to be this probabilistic approach which say, well, this measurement that you've done, it comes with uncertainty. It just because your time window is kind of, it's not a done deal. The time window is unclear. There are plenty of other things that are unclear. And so probabilistic forecasting is just a way to say, instead of having like a point indicator, let's fuzzify this thing to represent this sort of ambient, uncertainty that we have about the system. And why does it matter is that when you have computers don't have the bottlenecks of the human mind. They can process huge amount of information. So as long as this information is relevant to the task at hand, it will help. So it's a way to collect a lot more information about the situation, your system, your supply chain, your products, and whatnot, compared to point indicator. That's one thing. That's one way to look at it. So that's the sort of informational perspective. What have you collected in terms of pure information about your situation? That's one angle about probabilistic forecasting. The other angle, it's a completely different take. It's a risk management perspective, which is we ultimately need to have to be able to bridge our decision into some sort of risk analysis, euros. So we want something, fundamentally, we want something that will pave the way to get to this tangible decision, the one we were discussing at the very beginning. We are doing all of that in inventory optimization settings to decide the inventory quantities that we want to allocate, produce, purchase. And what is the sort of rationale to say that this quantity is good or bad? That's what is the rationale. Why do we pick that? And there is a sort of philosophical statement that Locke take, which is, well, we have to think in terms of euros or dollars of error and reward. Again, a company that's mission, the mission of the company is to be profitable. That's yes, there are plenty of other things. You may decide that your company must do something that makes sense for the world, etc. It's good. But if your company lose money, there is no company anymore. So the first step is to keep your company profitable, because whatever else you want to make with your company, if it's unprofitable, it's gone, and so it's no more a company. So you want to have your company profitable, and for companies that operate supply chains, margins are thin, survival is not a given. Plenty of large companies go bankrupt every single year. It is merely surviving is already very, very difficult. So we say, that's a bit a statement, that, well, in this context, the assessment should be the euros and dollars. There are plenty of details on how we count. We don't want to have like a short-term vision. There is plenty of other things attached to that, but they are not really our concern today. If we go back to probabilistic forecast, what I say is that probabilistic forecast, one way, more information about the system, but there is another way, another thing that matter. It is, I would say, it paved the way for classes of mechanism that let you bridge your financial vision with your anticipation of the future. And that's a very technical argument. This is literally, I'm just saying, one way. The first is not such a technical argument. This is just, if you go probabilistic forecast compared to point forecast, you are more expressive, you know more. You're kind of more accurate, although it is not accuracy exactly in the same sense. Just like for an image, having better contrast is not the same thing as having better color tones. It's both improve the image, but not in the same way. Same thing. So it's something like richer set of information. The other one is it lends itself into tons of very nice methods that are very suitable to re-express the quality of your decisions into euros and dollars. And that's through probabilistic forecast. You have this bridge that is, it's not a given, but at least you have plenty of methods that can bridge the gap. And if we compare that to ABC XYZ, that's why I say, it's kind of a dead end, is that ABC XYZ, if you want to bridge the gap between those euros or dollars, you have at the end of the game, and your matrix, there is no way to extend this matrix into some sort of method that would connect the two in ways that are sensical. Not that I know of, and there is plenty of reason to think that it's even if it's, again, given enough duct tape, you can do anything. But I would say I'm not aware of any sort of method that I would classify as sensible to go from this matrix to those euros or dollars. You can always engineer crazy amount of duct tapes that would give you that somehow. That's. But those methods are all the methods that I can think of would be better replaced by something that entirely bypass the matrix, the ABC XYZ matrix.
Well, there are some people who would point out that it's possible to leverage, let's say, AI or machine learning to basically bridge the gap that you just described. So to put it in your terms, I can put a really big piece of impressive duct tape on ABC XYZ and it will accomplish what you're saying.
So what you're saying is that you have a method that generates a matrix that is not really suitable for the purpose. So we end up with a garbage input. And now we want to reconnect that to something that is our true goal. And due to the fact that we have something like a completely garbage signal, that's our matrix, we need to go into the sort of duct tape on steroid, which is going to be able to connect something that is garbage into an output and bridge this gap by invoking higher powers of super fancy analytics to do that. You see, that's the sort of things where I say I would say just pause. Just pause. You're doing things that is like completely insane, and that's a bit like saying, you know what, my car is too slow. Let's engineer an aircraft engine on top of my car because my car is too slow. I say yes, but an aircraft engine is an incredibly complicated piece of engineering. Yes, there must be a way if you bolt somehow an aircraft engine on top of a car, assuming that the car doesn't just collapse on the weight of the aircraft, that somehow this engine will accelerate your car. But you see, this is the sort of things where, no. I mean, at some point you should, if your car is, it can't go fast enough, maybe you should reconsider whether the engine it has is powerful enough, or maybe there is just too much weight in the car due to things that you've put in the car. But you see, it's not saying that I have a problem and all my solutions are additive. I need to, let's bolt on this aircraft engine on top of my car so that I can make it faster. It's nonsense engineering. This is not proper engineering. And so when people say we have this matrix, we have, as humans, incredibly hard time to reconnect it in any sensible way to those dollars of error. Thus, due to the fact that as humans we are not able to bridge this gap, we are going to invoke some sort of analytical superpower, which is, let's say, magic, because when people say AI or machine learning, basically they say, I invoke the demigod of data analysis to do something nearly magical for me. And I say, well, sometimes it may work, but even if given, super sophisticated method, you could potentially get something. I would say this is nonsense all the way. This is like an incredibly, this is a contraption. This is something that is way too complicated for its own good. Quality engineering is about engineering things that are just that are as simple and as maintainable as you can make them, not as complicated as you can make them. If you introduce, I would say, undue complexity, then the net result for your supply chain might be that you spend more time debugging a super advanced machine learning algorithm that you barely comprehend, instead of focusing on basic problems such as the fact that your supermarket doesn't have the brand of diapers that parents want nowadays, and then fresh parents just walk away from your store just because they don't see the brand of diapers that they expect, and they just walk away. And that's something that your service level analysis won't tell you, and it's certainly something that your AI or whatever that you're kind of trying to system that you're trying to use to bridge your matrix to your dollars or euros of error is not going to tell you either.
Well, maybe it's to wrap things up a little bit, but in closing and succinctly, what would you say to people who are maybe on the fence about what you've just said? So they're still advocates for ABC XYZ, but they're open to being nudged towards the next step. What would you say? I
would say revisit your assumptions. Challenge your very vision. What is going into your bill of requirements? What is exactly that leads you to that, and don't get fooled by the sort of the tradition argument. We have done that for decades, blah blah blah. It worked, yes, but remember in Paris, people had for literally 2 millennia carried water in buckets. And two centuries ago, bucket water carriers was the #1 job in Paris. So it's not because something has been done forever that this thing is still relevant. I mean, it should, when something has been done forever, it should give you pause. Mm-hmm. It's probably something that at some point had some value under certain condition. So you should not just say it's old, thus essential, it should be discarded. That's not what I say. I say it should, if something has been around for a long time, don't discard it without thinking thoroughly about it. Mm-hmm. But then revisit your assumption, and for when I say to people who promote ABC XYZ is, have you made the sort of intellectual journey to challenge all the assumptions deep down that underlie the method. Don't ask me whether the method is right or wrong. That's not the question. You see, I've not said ABC XYZ should compute the average or the variance a different way. This is not what I'm saying.
Exactly.
I'm not saying that the method is wrong in the sense that it doesn't do what it's supposed to do. It does exactly what it's supposed to do, which is build a matrix, a discrete matrix aggregated, where products are aggregated into a short series of clusters, matrix cells, along 2 dimensions. It does exactly that. I'm not saying that the method is wrong in the sense that it doesn't do what it says it does. Yes, it certainly do. I'm saying that the very assumption and the very sort of line of reasoning and the sort of underlying vision that underlie this method, all of that is kind of bogus, and if it's not bogus, it's certainly obsolete. And that is what you should be looking at.
Well, if I can duct tape one little thought onto the end of that, actually, in terms of the reasoning, I would say, personally, in terms of ambiguity tolerance, 2 seemingly contradictory things can be true simultaneously, and I think that's actually a key detail as well. So, for example, perhaps you have used ABC or ABC XYZ for decades, and it has worked for you. That can be true, but that says nothing about the statement that there are better methods, or it doesn't actually speak to the correctness of the method. So 2 things can be true simultaneously. And for some people, that's kind of difficult to comprehend. I understand that.
Yes, that's a confusion of factors, and that's all over the place, because the reality is ABC XYZ, when you say it had worked for you, I challenge that in the sense that ABC XYZ doesn't give you the final reorder quantities.
Nope.
So the problem is that there is other steps after that to get to that, and there might be tons of human judgment involved. And what I say is, remember, we started with the sort of persona of having just a store manager that just look at a single spreadsheet, my sales volume, and what do I pick for my products, and be done with it. And we have plugged in the middle this matrix. But if your process is create a fancy matrix, pretend that you're a scientist, and look fancy in front of your colleagues, look smart in front of your colleagues, and then discard the matrix and go back to your ancient ways, which are not as scientific looking, but actually superior, and be done with a job, you might very well end up saying that it worked very well for you, in the sense that it was giving your colleague a rational, it was giving you maybe a sort of sense of illusion, a delusion, of your own, on whether this part of your work was actually contributing to anything. And in the end, you were doing something entirely different to come up with the only decision that mattered, which was the final inventory decision. And that's the thing, is that due to the fact that supply chains are very complex and opaque, and you can do a lot of things in between that serve no purpose, and that seemingly, serve a great purpose. There are, if you look around the world, there are plenty of primitive tribes that will have plenty of, let's say, rituals to invoke the rain. I don't think there will be many people nowadays that would say that dancing, for the rain will have, an impact on the weather.
Improve lead
and improve, the yield of your crops. But people would say, well, we have danced for the weather for thousands of years, and then there was rains, and then we had a good harvest. Yes, you do, but maybe there was like some steps in what you were doing that were just completely useless. So in the end, that's what you really need to assess, is, does this step really contribute as much as you think it does to the quality of the final output, which is a tangible decision, not the sort of artifacts you come up with along the way. And then, is there alternative methods that would be better? Because ultimately, if you have something that works for you in the sense that it works at all, again, we are back to carrying water in buckets. It certainly works. It's just that there are alternatives that are enormously better.
Well, exactly what I was getting at, that 2 things can be true simultaneously. You can carry water in a bucket, But at the same time, you could also transfer it in a boat or anything significantly larger is what I'm saying. But again, two things can be true simultaneously, and reconciling these, or rather, not reconciling, acknowledging that there is often ambiguity between concepts, or for the fuzziness that you often talk about.
Yes, and
but this is a philosophy. This is a
exactly. But you see, you need to
point.
challenge when people say, and I think on this sort of recipes or practices, I would say simple practices that I see in supply chain, you really need to challenge what do you mean by it work for you?
Exactly.
What does it mean? Because you see, that's not that is very much an anecdote.
It's not falsifiable, really.
I'm not saying that it's wrong per se, but if all you have to say it was kind of right, it is I would say in a modern supply chain, very distributed, where your human perception is very limited. Again, you could say the validity of this claim, it worked for me, is absolutely not the same if you're dealing with a small system in the hands of one person, or a super complex tentacular supply chain that you can't observe in its entirety. You see, again, if there is like a store manager who manage one shelf, I say, you know what, it looks good. For me, it looks good. I look at this shelf and I say, this is exactly what my clients wants. I would say, well, that's probably a very valid claim that you're making. I trust your judgment. Why? Because that's something that is in front of you. You have a sense, as a human, you have a sense of the system. I have a shelf. I can put myself in the shoes of my clients. I use my empathy. I look at that. I have all the relevant information right in front of me. I can pass a judgment. And this judgment is most likely relatively reasonable, assuming that person is on good faith and whatnot. Mm-hmm. Now, is it the sort of situation that you face in supply chains? I would say usually not at all. Mm-hmm. The typical supply chain situation is you're a clerk in an office 1,000 kilometers from the place where the goods are going to be shipped, consumed, and whatnot. You're not looking at a shelf, you're looking at an Excel spreadsheet. You have dozens of products that where you have in your life, you have only seen the product codes. You have usually most of the product codes, you have never seen the products for real. So you don't even, again, I've seen, and even if you have seen some, you certainly not have seen all of them. And then you're serving customers that you've never seen, and the data is presented from a system that is super complex and that you barely understand, that your ERP and whatnot. And so your rationality is that you're trying to use your own human rationality to cope with something that is only a tiny, tiny part of the picture. And that I very much challenge, how much you can say it worked. I could use my own judgment to tell you it worked. If it's something that is very localized, where you see the whole thing, mm-hmm. I would say, yeah, maybe you can't explain me why it works, but I trust your judgment. If you're looking at something that is not even 1% of the total, and you tell me it worked, I say, no, you don't see. It's just that it does what you're used to see mm-hmm. in this 1%. That's when you say it worked, you're just saying, what you have in front of your eyes is not deviating compared to what you've gained to be accustomed to seeing for this 1% of the puzzle that you're looking at.
Well, Joannes, I think we've covered a tremendous amount of ground today, and I don't have any other questions. So, Joannes, thank you very much for your time, and thank you very much for watching. We'll see you next time.